Okay. So for question number 7, it says from 1940 to 1980, the average size f of a US farm can be modeled by the function, and they give us a function. So this is the equation that we're working with right here. And it says T is the number of years since 1940. So that's really important. So it says, what was the average farm size in 1950? So in 1950, that means for T, I'm going to use 1950 minus 1940. So T is equal to 10. So you're going to type that in your calculator to find the farm size, F. F is going to equal 174 E, and then it's 0.022 times 10. So go ahead and type that in your calculator. So when you type that in your calculator, you're going to have 174 E. You have to hit second function ln to get your E. E is a constant, kind of like pi. And when you do, you should get that the farm size is 216. It doesn't tell us where to round to. So I'm just going to round to the thousands place. 817 acres. But for part B, it tells us the farm size and it wants us to find T because it's asking us when was. So that means they want us to find time. So let's use this same equation right here. 400 goes in for F. The first thing you want to do is divide both sides by 174. And that gives us approximately 2.299 equals E. The opposite of E is ln. So when you put an ln on both sides, it cancels out the E. And you're left with the natural log of 2.299 equals, okay, let me see if I can squeeze this in. So the natural log of 2.299 equals 0.022t. We're going to divide both sides by 0.022. So in your calculator, go ahead and type this in. And see what you get for T. And you should get T is approximately 38 years. But remember, T is the number of years since 1940. So you're going to take that 1940 plus 38, and you should get around the year 1978. That is when the farm size would have been 400 acres. Any questions about number 7?
No.
Okay, so let's look at number 8. For question number 8, it says the rate at which a liquid vitamin breaks down in the average human body can be modeled by the function. So we have our function. Y is the millimeters of the original dose and X is in minutes. How long will it take for the original dose of 15 milliliters to be reduced to 5? So Y is the original dose. Y is the milliliters of the original dose that remains after X minutes. So in this equation, Y represents the ending value. D represents your beginning dose. And T is the time in minutes. So it says, how long will it take for it to go from 15 milliliters to 5? So that's going to be 5 equals 15. And then we have this 0.95 to the power of X. You always want to isolate the base first. So that would be a 15. So when you divide that, you get 5 over 15, which is approximately 0.33, repeating itself. We'll round that to a decimal. And that equals 0.95 to the power of X. So the opposite of an exponential is a log. So we have to put in a log. In the last example, we could use a natural log because that was the opposite of E. So we had to use a natural log. But we don't have a log that has a base of 0.95. So it doesn't matter which one we use. We can use a natural log or a common log. I'm just going to use a natural log again. And remember, whenever you put in a log, that exponent moves to the front. So you're left with the natural log of 0.33 equals X times the natural log of 0.95. This is a number. And anytime you have a number being multiplied by X, we would do the opposite, which is divide it. So we're going to divide by the natural log of 0.95. So in your calculators, if you type in the natural log of 0.33 divided by the natural log of 0.95, that is going to give you your time in minutes. So you should get T is approximately equal to 21.614 minutes. And again, it doesn't tell us where to round. So I am rounding to the thousandths place. If this was a test question and it does not tell you specifically where to round, then you could just choose where you want to round to, and that's fine. And just if you were to put in log of 0.33 divided by log of 0.95, you still get the same answer. So again, it doesn't matter which one you use. You can use a natural log or a common log. So, all right, so let's look at our last example.
Miss Bryant,
Yes,
I have a question for number 8.
okay.
Couldn't you do the natural log of 0.33 divided by wait? Couldn't you do the natural log of 0.95 divided by 0.33 and you would get the same answer, or would it show a different answer?
Oh, yeah, so you have to put it in as the natural log of 0.33 divided by 0.95.
Uh, okay.
Okay, and our last one, for example 9, it says you win the lottery, you get $1 million, and you decide you want to invest all of the money into a savings account. However, you have two different plans. In 5 years, which plan will provide you with more money? So for plan A, it's compounded each month, so N is 12. So we'll do plan A in purple. So we're starting off with, this is our formula. Because our frequency is not continuous, this is the formula that you're going to use for both plans. So for plan A, you get 4%. So your starting balance is $1 million, 1 with 6 zeros. Your interest rate for plan A is 4%. It's compounded monthly. And we want to know how much money in 5 years. So in your calculators for plan A, you're going to type in $1 million. And then 1 plus R over N to the power of N times T. So let's see how much we would have. We would have $1,220,996.59 if we did plan A. For plan B, let's do that one in red. We still have the same $1 million to start off with. This time it compounds, our interest rate is 8%. And it compounds every 2 months. So that means that it would be 6 times in 1 year instead of every month is every other month. So in the course of 12 months, interest will be compounded 6 times. And again, T is 5. So we have 1 million. Make sure I have 1, 2, 3. Oops, one more, one extra zero. Okay, so 1 million. And then we have 1 plus 0.08 over 6 to the power of 6 times 5. So type that in your calculator. it looks like you get $1,487,886.72. So the better plan would be Plan B. So Plan B will provide most money in 5 years.